Right now, throughout the globe and throughout the world, there is a serious concern about the kind of waste we are generating across the globe. So, using these IoT technologies, how we can best utilize these IoT technologies for waste management. That is today's topic. We'll see how IoT is implemented and how we can utilize this technology for the waste to energy technologies. Next. So today what is the agenda is that, so we first will discuss about introduction to IoT and waste management and waste to energy fundamentals and basic IoT architecture and applications and what are the case studies and implementation. Also we look at what is the future outlook and recommendations. Next. So coming to introduction, you can see the entire how the waste is collected and how the garbage system is collected and how the entire processing is happening. You can observe in the pictorial representation. So what happens in this? There is a real-time monitoring of waste levels, automated collection scheduling and optimized resource allocation, enhanced data-driven decision making. These are the preliminary introduction to the IoT management, waste management, and by 2025, an estimate of 35% of global smart cities will have adopted this IoT-based waste management system as a core infrastructure component. So this is the introduction to the IoT. Next. So if you define it, what is the IoT a core concept? You will have a sensors and device, and there is a communication protocol connectivity, and the kind of data you collected, there will be data processing and interpretation, and finally the end user is the applications. Next. So what happens to when it goes to the digital transformation in waste management? So when you talk about waste management in sector in undergoing as a fundamental shift, you can take it as a static collection of schedule. For example, the waste should be collected first and through what? As a visual bin inspection and automated fill level monitoring. So where the bins has to be, whether it is filled or not, we will check it up and react to maintenance, and next we can take it as a estimated matrices in real-time performance data. Next. So what is the present traditional waste management challenges? There is actually insufficient collection of routes. So you can see in the roadside there is a insufficient collection for the waste management. So at the same time there is a resource overuse. So you can say while you can see there are a lot of GHMC vehicles are going, and because of many vehicles are used, there are a lot of fuel consumption will be there, and vehicle wear and labor, and all these things is a burden to the government and for us also. So second thing is limited visibility and manual sorting inefficiencies. These are the few traditional waste management challenges which will be addressed to using this IoT technology. So if you take in a global scenario, what is the waste crisis, and this is a 2.24 billion metric tons of waste is generated, and by 2050 you can expect it goes to the 3.4 billion. So overall it will have a growth rate of 45%. Next. So then if you have this much waste, then what is the push for the waste to energy? So how this waste can be converted into energy? Then what are the constraints we have? The first one is landfill constraints. If a lot of waste is becoming more, there is a lot of spaces will be occupied. That is one of the one constraint. Because of this waste management, the another implication is climate imperatives. So you need to utilize this waste and process it and generate as a some energy. Then only we can reduce the landfill as well as climate imperatives. And there are also regulatory pressure and energy security also. So you need a lot of energy. By using this waste, we can generate some energies using technologies. Next. So if you come to the overview, what is waste to energy technologies? So how this waste is generated into energy technology? There are two methods are there. One is thermal process and biological process. What is thermal process? Where you take a waste and use some up to 850 to 1200 degrees of centigrade of temperature, then you use this thermal process to generate some kind of energies. This is the thermal process method. And second one is biological process, where we will have a here bacterial decomposition without oxidation. So this will generate a mechanical biological treatment, combined sorting and biological processing. So these are the two methods where the waste can be converted into energy as a technology. Next. So this is the waste to energy process explained. So the this is the incineration is a process, thermal process, and like earlier I told, as a biological process, this is the method where it is clearly identified that this thermal process reduces waste volume by up to 90% and requires flue gas cleaning system and modern plants including energy recovery. This is one of the method. And second one is using biological process, where it produces a biogas and methane and 40% of carbon dioxide. It operates in oxygen free environment, and also it digests byproducts used as a fertilizer. So if you use a biological process, there are other byproducts also. Those are illustrated here. Next. So this is the if you take it in economic and environmental impact, what happens to waste to energy technologies? So you can reduce the landfill reduction up to 15 to 30%, and energy efficiency will be 60%. And what are the power you can generate up to 500 kilowatt per hour per ton, and what is the carbon will be getting reduced using this converting in waste to energy. It will be 1/3 of carbon reduction will be there. Next. So if you see what is the architecture of IoT enabled for this waste to energy technologies, there are 4 layers are there. The first layer is data collection layer, communication layer, processing layer, and application layer. So the first thing will be collecting the data by using the network, and this one we need to transfer the data. You need to process the data, then use as ultimately applications user end. Next. Then what are the basic devices in the IoT? So if you know Internet of Things, the basic devices are like this. So there is a few sensors like ultrasonic and weight sensors, temperature and humidity, for GPS tracker for vehicle monitoring, and RFID tags where the vehicle is to track that vehicle, the GPS tracker is required. And also to transfer the data, there are some cloud platforms to send the data and visualize the results. Next. So then coming to what is the system workflow when it comes to the waste collection to energy. The first one is, as already told, data collection, route optimization, smart routing, and processing of the data. Next. Then when it comes to the what is the real-time monitoring analytics, so using this data processing scale, roughly around 200 data points processed by city scale pilots. Each smart bin generates 8 to 24 reading daily. Collection vehicles transmit location data by 30 seconds. So it generates the approximately plants monitor around 500 plus processing parameters when you take a real-time monitoring, because see, now using this technology in real time we can know what are the parameters are changing immediately. So this is the in other countries they are using, there is smart bin technology where you have that garbage bin will be very advanced technology where it can show automatically bifurcate what kind of waste it is and whether it has fulfilled, whether it has to be make it empty. All these things will happen by using this smart bin technology. Next. So again there is a challenge for across the globe. You will the waste will be spreading over. You need to collect each and every place by going physically. This is the one of the challenge. So in real time we should know how effectively you should collect the waste and send to the plant, and you need to process it. So there you need to have a dynamic collection of this one and entire to increase the energy level. Next. Then you have seen here this is like looking like our GHMC garbage truck where it is collecting some waste. Now if you see using this IoT technologies on this truck, there are multiple sensors are mounted on this truck where it will collect all the data, and it will provide the live location of the truck. Also, it will bifurcate the waste depending on the type of the either it is a plastic or wet or a dry kind of waste. Next. Now again, by using this smart sorting, you need to, after collecting, you need to sort it out the wet or dry. So there are some kind of near infrared spectroscopy which identifies plastic items. At the same time, computer vision recognize objects where it will identify the materials. Also magnetic sensors for ferrous materials, and eddy current separator for non-ferrous materials. Weight and density sensors where it will categorize the mixed materials. These are the sorting mechanisms for the no, go. Where are you going? Next. No, come down. Okay. So in IoT, material recovery from the waste to energy technologies. So the first thing is contamination detection and moisture analysis and calorific value assessment. These are the few sensors which will be used for this material identification. Next. So when it comes to the integrated and also after making this entire process in automatic as well as automation in this plant, you need to have a maintenance also for this plant. What are that maintenance? You need to have a condition monitoring, pattern recognition, schedule intervention, and early warning also. So when it comes to we get lot of data about this, how much waste has collected, and how much is processing, what is the energy is generated. So there are a lot of data analytics are involved in this. So coming to the advanced analytics applications, where you have a machine learning algorithms like waste flow forecasting, process parameter optimization using AI, and anomaly detection using algorithm identified abnormal operations, energy output prediction, how much energy is generated, also what is the emission is controlled, what kind of carbon dioxide is reduced. These are the data analytics we can monitor using advanced AI algorithms. Also, because we are making this kind of method across the globe, and it will be spread across a lot of huge area, you need to send this data using the cloud data only, because the globe is very vast, where we need to transfer the data to the globe. Then only we will be able to transfer the converted energy into will be transmitted to the for society applications. Next. Also, there are cyber security issues also in this. So what are the cyber security? You need to have a end-to-end encryption for the data transmission, because you are using the cloud. At the same time, secure authentication for protocol for all the devices, because you use lot of instrumentation and sensors. You need to have a security for that. And also isolated operational networks, redundant systems for critical functions. If suppose if some plant catastrophic effects are happening, then you need to have a redundant system for that. And also frequently firmware updation is required. So physical security measures also required for the field devices. Coming to what are the energy output monitoring. So using these two processes like thermal and biological processing, there are some power generation, thermal energy, biogas, and grid integration. These are the kind of energy outputs we can generate using this methodologies. Next. So coming to what are the emissions and environmental compliance, high energy fractional identification, organic steam separation, contamination detection, priority routing. These are the 4 important parameters we will look after when it is segregation. Next. Then IoT bioenergy from waste. So this is one of the sensor where you use for the pH monitor, and this one. This is one of the sensor we use in IoT. Next. So for the gasification and pyrolysis, this is the method we use: thermal profile monitoring, pressure control, and synchronized gas analysis, and feed logs calibration. Next. Then what are the hybrid systems in IoT and AI robotics? Here we use next generation integration like AI vision systems, robotic sorting, IoT sensor networks, digital twins, autonomous vehicles. These are the next generation robotics we use for this kind of application. Also, right now everyone is very friendly to use mobile apps. That's why each and every technology is coming into the mobile, where you can user friendly have all the kind of controls and monitor the required data processing. Then what are the interoperability standards? So you need to follow certain standards while you process this kind of plants, where you need to generate power means as per the regulations we need to do the processing. Next. Then whatever the data you collected, always better to have a interconnected to the grid and smart systems, because we can increase the production rate, and as well as we can make the better management to the process application. Next. So what are the economic models and funding? So depending on the hardware, software and network support, so there are public and private partnerships. Presently, mostly public and private partnership, they are making this kind of technologies to implement in the society. Next. Then what are the risk assessment in IoT? So there are 4 things are there, like data loss, connectivity, sensor reliability, cyber security threats, and system integration. So you need to have these 4 things in mind when you implement it as a risk assessment. So when it comes to the what is the market growth? So when you generate energy from this waste, so this is the graph where linearly you are able to generate a few kinds of benefits like this much of energy. Next. Also you need to see the what are the key policy and regulatory trends. So always you have to see as by the norms you need to establish this kind of systems, and we need to implement it. Then only we will be able to achieve the kind of requirement. Next. So when it comes to the environmental benefits, so you can have CO2 reduction of 30 to 50%, and volume we can drastically reduce up to 85%, and transport emissions, like when you go the vehicle, there are a lot of emissions are there, we can reduce it to up to 29%, and the air quality will be improved by 22 up to 20%. Next. So again, the life cycle analysis and sustainability. So the comprehensive sustainability assessment must consider e-waste generation from sensors, energy consumption of data sensors, and battery disposal and recycling. These are some of the sustainable things where you need to keep an eye for our life cycle analysis when you implement this kind of advanced technologies. Next. Then coming to community scale systems, there are decentralized WT solutions like solar powered sensors and community scale and modular pyrolysis, mobile applications, microgrids and remote monitoring. These are the few things we need to decentralize for the WT solutions. Next. So this is the overall picture of the block diagram, where you will have a transparent waste tracking, smart contracts, carbon credits, energy trading, supply chain verification. Next. So then coming to, by using automation and AI, then there is a drastic change in the autonomous collection and smart materials and cognitive sorting, digital twins and quantum computing. So by using this, you are able to achieve using AI and other technologies, the full automated system for the entire process. Next. So when it comes to the overall the plant operation and at the finally to generate this energy from the waste, it follows as a circular economy, like informed design, like IoT data, sustainable production, responsible consumption and smart collection and resource recovery. It's a circular economy. It will be processed like a circular motion. Next. So building a workforce of the future. So by doing this, you have now there are a lot of sensors are requirement is there, and there are a lot of automation, and you need a lot of people to operate this, to generate this kind of. So the lot of industry and public has to be work together to make this kind of thing. So in this we can have a lot of skill development advantage also for this kind of applications. Next. So funding and scaling innovation. See, coming to when it comes to you need a concept development and prototype testing, pilot implementation, commercial deployment, global scaling. So always these are the 5 steps has to be followed when it comes to the funding and scaling. So any implementation has to go these 5 stages. Next. So what are the recommendation policy makers? So insensitive digital infrastructure, streamlining permitting, promote open standards, invest in workforce. These are the things, recommendations of the policy makers. Next. So what are the recommendations from the industry leaders? So always they say 3 things: prioritize data integration, adopt hybrid technology, embrace collaborative models. By following these 3 things, we will be better manage to generate this waste to energy technologies. So coming to the what is the conclusion and key takeaway from this entire technology? You can say IoT WTE integration creates measurable efficiency gains, environmental benefits and economic value, and technology convergence like sensors, networks and cloud computing and AI enables unprecedented optimization overall system. Also real world implementation demonstration clear ROI generation using this kind of technologies, and market growth is very accelerating and cost reduction by using regulatory pressure increases. And what is the path forward for this? So start with the pilot projects and demonstrate a small building institutional support, invest workforce development alongside technology implementation, engage stakeholders early to address concern and ensure adoption, and measure outcomes comprehensively to guide the continuous improvement. So these are the path forward where you can generate a clean and wonderful environment by using this kind of technologies. Thank you.
You came here all the way from different conditions, and we know from you how to convert waste to wealth and how to make the business from waste management. Thank you very much. Thank you very much, sir. And thank you, audience. Your good support. Thank you very much.